Basics of counting problems. Hi, in this video I'll talk about the very basics of counting problems. This will help you solve problems like, suppose there's a company which has 2 employees and 5 printers, for example. In how many ways can you assign these 5 printers to these 2 employees? These type of problems and many such problems. So let's look at what counting problems, how can they be solved. So for solving counting problems, there are just simply 2 basic rules, 2 very simple rules: the product rule and the sum rule. You don't have to remember these names as such, you only have to remember the methods which I am going to tell you. So the product rule says that, for example, see the definition. You don't have to remember this, I'm just saying it. The product rule states that, suppose there's a task which can be broken down into a sequence of 2 tasks, such that if there are n1 ways to do this task, the first part, then for each of these n1 ways, there are n2 ways to do the second task. Then to do the total task, there are n1 multiplied by n2 ways. So what does this mean? Let's look at an example. Let's look at this example. Suppose there are 2 employees in a company. The company has only 2 employees and the company purchases a building that has 12 offices. Now you have to assign these 12 offices to these 2 employees. Offices labeled like O1, O2, O3 to O12. Employees names are, for example, A and B. Now you have to assign these offices to these 2 employees. You can give A O1, then B O2. This is one possibility. A, you can give him office number 4, and you can give B office number 6. This is another possibility. This is one way of assigning offices. This is another. How many such ways are there in total? Let's look at how you will approach this without knowing any formula. Suppose the first employee comes and you have 12 vacant offices, and you just have to give this employee an office. How many choices do you have? You have 12 options. You have 12 choices. You can give him any of the offices among these 12. So you have 12 options to choose from. Now once you have given this employee an office, you are left with 11 offices, and the second employee comes. How many choices do you have for him? 11. You can give him any of these 11 offices, not 12, because one you have already given to this. So there were 12 ways to do the first part, and for each of these ways there are remaining 11 ways to do the second part. This is the product rule, and these are the total number of ways you have to assign 12 offices to 2 employees, equals 132. Let's look at a few more examples. So for second example, we have an auditorium which has a lot of chairs, and the chairs need to be labeled, and the labels are of this form: a number, a letter, and then a number up to 100. The number is from 0 to 100, from 1 to 100, sorry. and this is the numbering format of the chairs in the auditorium. So how many chairs can you label if the numbering format is like this? A letter and then a number from 1 to 100. How many such chairs can you label? So we will use the product rule here again. For the first part, for the letter, how many choices do we have? There are 26 letters in the alphabet, so we have 26 choices. And for each of these 26, how many choices for the number do we have? We have 100 choices. So in total we can have 2600 chairs labeled differently, uniquely. Let's look at another simple example. How many different bit strings of length 7 are there? Now someone asks you this question: how many different bit strings of length 7 are there? You can answer this using the product rule again. A bit string, a bit can be either 0 or a 1. A bit string is a string made up of zeros or ones. So a bit string of length 7, how many such bit strings can be there? Now this place can have a 0 or a 1. This can also have a 0 or a 1. The same for these. How many such bit strings can be there? Let's look at the product rule again. So for the first part of the sequence, we have 2 choices. For the second part, for each of these choices we have in the first part, for each of these we have 2 choices in the second, and for each of these we have 2 in the third. This is how many bit strings, this is how many different bit strings we can have of length 7. So this was the product rule. So now let's take a look at the sum rule. The sum rule is actually a lot simpler than the previous one. The sum rule states that if a task can either be done in n1 ways or it can be done in n2 ways, then the total number of ways to do this task is n1 plus n2. Let's look at an example. This is very simple. You won't even know that you are using some rule. This is just common sense. Suppose in a college there is a list of projects. There are 3 lists of projects. The list 1 contains the titles of 23 projects. List 2 has 15 projects, and list 3 has 19 projects. Now a student comes and he has to choose a project from these lists. How many choices does he have? How many possible ways of choosing a project among these? So from list 1 he has a choice of 23, from list 2 15, and list 3 19. If he had to choose one project from any of these lists, he has a total of 23 plus 15 plus 19 choices. That is 57 choices. It's that simple. This is the answer. So this is some rule. It is that simple. So now let's look at some more complex problems which are not as simple as the problems we already discussed. So let's look at one such problem. Passwords. Suppose our computer accepts passwords of, say, length 3 character passwords, and the passwords can be made up of uppercase characters and numbers. Suppose there is one more restriction, that the passwords must contain at least one number. So now how many such passwords can be there? How many passwords can exist? So if you were to solve this problem and you didn't know any of the methods, how will you approach this? You have to fill 3 places. You can use uppercase characters and numbers. There are a total of 26 uppercase characters from A to Z and 10 numbers from 0 to 9. So you have to fill these places, and you have 36 choices for each of these places. 36. Now let's take this restriction into consideration. You have to have at least one number in the password. So the number can be here, can be here, or it can be here. At least one number. At least one number means one of these spots. For one of these spots you have only 10 choices, and for others you can have uppercase characters or numbers. For others you have 36 choices. So let's say the number comes in here. You have 10 choices here, and for here and here you have 36 choices. This is case 1. This is case 2. Here 36, the number comes in between. And this is case 3. The number comes at the end, and for the other 2 you have 36 choices each. These will be the 3 cases. At least one number, and the rest can be uppercase characters or numbers. So using sum rule, you add up these. Using product rule, it will be 36 10 36. And then you add these, and that will be your answer. But this is wrong. So this is how you might normally approach this problem, but what you are doing wrong is that you are counting a lot of duplicates. That is also called as double counting. You are counting many of the possibilities twice. For example, let's look at this password, say 12A. Suppose this is a password. So you are counting this in this case. It follows this case 1, 2, A, and it also follows this case 1, 2, A. So this password has been counted twice in your answer. So you are counting a lot of things multiple times. So that is what you are doing wrong, or you might be doing wrong if you were to solve this problem and you didn't know the ways. So to get rid of double counting thing, what you do is you approach this problem in this way. Suppose it's called the subtraction way or the opposite way. Let's look at it. So we have 3 places, uppercase and numbers, 36 possibilities each. So what we will do, and there's also at least one number must be there. So what we will do to find the answer is that first we will calculate the number of all strings made up of 3 digits that follow these. All strings of uppercase characters plus numbers of length 3. This will include all the strings without this restriction. It will also include strings that have no numbers in them, that don't follow this condition, at least a number. It will also include ABC. It doesn't have a number. So all strings of uppercase characters and numbers of length 3 minus the strings that have no number. This will give us the strings of length 3 made up of uppercase characters and numbers that have at least one number. This is way easy, and this is called as the subtraction way, the opposite way, whatever you want to call it. This is a method of problem solving, and it can be used in many of the problems, and you will use this in a lot of problems in the future. The way to solve this problem in the brute force way would be very difficult to count the exact number of methods. Let's first solve it this way. All strings of uppercase characters plus numbers, we have 36 choices for each, so it will be 36 3. The strings that have no numbers, means they are only made up of uppercase characters, so we only have 26 choices for each. Minus 26 3 equals answer, which would be 29080. So this is the subtraction method of doing this problem. If you don't want to follow this method and want to do this directly, or if you just want to know how this problem can be done direct way, it will be a very long process, a very long and complex process, but just for the sake of it, let me show you how it's done. So previously what you were doing is you were counting these 3 cases: 10, 36, 36, 36, 10, 36, 36, 36, 10. So you were counting a lot of duplicates. Let's see for this string 1 to A, it was in this and in this. What you have to count is, you have to make cases taking into consideration, taking into thinking that you are not counting duplicates. So first case will be this same 10, 36, 36. Okay, so for the second case, you don't have to make the first place a number, we have to restrict it. So the first number that appears should be in the second place. All those strings, in which the first number that appears is in the second place, and after that there can be any. So the first position will have 26 choices, and the third case would be all those strings in which the first number appears at the third position. 26, 26, 10. So how many strings for this case? I think 12960. And for this 9360. And for this case 6760. Adding these gives you 29080, the same answer. So this is the subtraction way of doing this. So I hope now you know how to solve some problems. So for more videos on discrete maths and computer science in general, subscribe to Simple CS. Thanks.